Hey guys, here is day 2 of section 6.6. I'm only going to go over writing the equation of a sine function given its information. I'm not going to worry about transforming the other 4 trig functions using their phase shifts. I just don't think in this time it's the most important, and I don't want to overcomplicate anything. So we'll just stick to sine and cosine. All right, so remember, in section 6.6, we saw a phase shift, shifting the graph to the right or left so many units. So when you're graphing transformations of this form, this is what the equation is going to look like, right? And our book, because they're so big on transformations and they want to pull out this phase shift, they make you rewrite this as y equals a times the sine of, they make you factor out the omega so you can see the phase shift separately. So it'll be omega times x minus phi over omega, and then plus b. Okay, and then they'll make you rewrite this one as well by pulling out that omega. So y equals a times the cosine of omega, pull it out, x minus phi over omega, and then plus b. And again, what this does is it allows you to really see what your phase shift is going to be. This graph is going to be shifted phi over omega units to the right or left, depending on whether this is plus or minus. This graph is going to be shifted to the right or left phi over omega units, depending on whether this is plus or minus, okay? So again, it just lets you really see what your phase shift is. All right, so your amplitude, right, is always found by taking the absolute value of A times your original amplitude, which the original amplitude of sine and cosine was 1, and then that gets you an overall amplitude that is the absolute value of A, because the amplitude is considered the distance or half the distance in between the highest and lowest point, so it should be given as a positive number, even though we know A can be positive or negative in the actual equation. All right, your period is always found by whatever you divided or multiplied the x's by. So the period for each one of these functions, sine and cosine, used to be 2 pi. But since the x's are being times by omega, which means that in reality we have to divide by omega, we now have to take the period and divide it by omega as well. So these graphs always have a period of 2 pi divided by omega. All right, the phase shift, which is now your horizontal shift right or left, is now always given to you by phi over omega units. All right, and then your vertical shift is always easy. It's your b, right? Your plus b on the end. You either go b units up or b units down. Okay, all right, perfect. So look at example 1. They want you to write the equation of a sine function that has the given characteristics. It has to have an amplitude of 5, it has to have a period of pi units, and it has to have a phase shift of 1/2. The only type of transformation they didn't give us any info on was a vertical shift, so it must not have a b value. It must not be shifting up or down because they didn't give us that. If they did have a vertical shift, it would say vertical shift -3 or vertical shift 4, and then you would just add on the +4 or -3 at the end of whatever equation you write, okay? All right, but here we go. Let's use our go-to get started formula. So y equals, now here's the thing, right? A is always what you're timesing your y values by, right? Which therefore is what you times your amplitude by. And since they had an amplitude of 1, your amplitude automatically becomes A. But you have to understand something. The amplitude is described as a positive number. We take the absolute value of this. But A could have been a positive number, causing no x-axis reflection, or A could have been a negative number, and then it causes that x-axis flip or x-axis reflection. So technically, A could have been a positive or a negative number. So there's 2 options as to what A could have been. So even though they said 5, that's because you took the absolute value of 5. It could have been 5 or -5. So you want to keep in mind that there really are 2 possible equations that could have had an amplitude of 5, okay? All right, so then times the sine of omega times x minus phi over omega, and then plus b. But because this one doesn't talk about a vertical shift, I don't have to worry about the plus b part, okay? All right, so here we go. So we can get started pretty quickly. If our equation or graph has to have an amplitude of 5, then we know A has to be plus or minus 5. So we can plug that in right away. It's got to be plus or minus 5 times the sine of. Well, what's omega? Well, omega directly affects the x's and the period. Your new period is pi units. So remember, our period of these transformed graph is always found by taking the original period, 2 pi, and dividing it by omega. So we have to make sure that 2 pi divided by omega ends up equaling pi, the new period. So what's going to make 2 pi over omega equal your new period pi, right? So then throw it over 1, cross multiply. I'm going to get omega times pi equals 2 pi. Let's solve this for omega. And you find out that omega must be 2. So now you can put 2 in for omega times x minus is what it says, but remember it could be plus or minus phi over omega. Phi over omega is always your phase shift, okay? Your phase shift is clearly 1/2. So it should be minus, because that's part of the formula, and then 1/2 goes in. Okay, all right, now you've technically written it, but they want you usually to rewrite it back in the original form. So we're just going to distribute the 2. So in order to have all of these transformations happen, the equation must have started as y equals plus or minus 5 times the sine of 2x minus 1. And then there's your written equation that meets all of these conditions. Now, here's another thing you can do, right? You know your phase shift is always phi over omega, right? So once you find omega, you can use your phase shift, which is phi over omega, and set it equal to 1/2. Right? And then if you put your omega in, which is 2, you then find out that phi over 2 equals 1/2. Now again, you could see right away that when omega is 2, these line up. So what does phi have to be to make this statement true? Phi has to be 1, right? Or if you cross multiplied, you would have gotten 2 phi equals 2, and then phi equals 1. You still would have found out that phi equals 1. So if that's the case, if you find out what omega and phi are, then you can plug right into the original equation, which would be y equals plus or minus 5 times the sine of 2x minus 1, and then we don't need the plus b. So by finding omega and phi directly, you can plug into the actual original equation if need be. That's just another option, okay? But we already got the exact same equation, right? If I plugged in to the original formula, I'm not on the screen. If I plugged into the original formula before they took out the omega, y equals a times the sine of omega x minus phi and then plus b, right? I don't need the plus b because there's no vertical shift. If I plugged my information right in now, y equals plus or minus, we said a has to be 5, times the sine of omega, we said is 2, so 2x minus phi, we said phi is 1, and then I don't need the plus b. And you get the exact same equation either way. I tend to stick with this way, but either one will work, all right? If you want to solve for omega and phi and plug them into the original equation, or whether you want to start with this equation and find omega, and then you can use the phase shift as your omega over phi, okay? All right, let's try another one. What if they want you to write the equation of a sine function that has an amplitude of 4, a period of pi over 2, and a phase shift of -3, right? Which means it's going to go left 3, which means it must have been